Hey everyone, so before we begin with our video, we would like to make a small request. Kindly subscribe to our channel and like the video if it helps you, and also share it with your friends who may benefit from the same. So hey guys, in this video we'll be showing the effect of variable irradiance on a PV MPPT system. So this is our PV panel, and if you can see the plots for various temperature and irradiance values, as you can see for different irradiance values you have a different point of maximum power which corresponds to different points of voltage and currents, right? So we'll be simulating a 24-hour simulation of a variable irradiance and seeing how the output would change for power, voltage and current, and refer to our previous video where we discuss how to import the 24-hour values of irradiance and add it to a PV system. So here it's added to a PV system with the temperature being constant. So as you can see, time is 2 seconds right now, so that corresponds to 2 hours for us, because we're taking 1 second is equal to 1 hour. And from the 1D diagram you can see the irradiance is actually is 0 till like 5 seconds or 6 seconds. So at t is equal to 6 we should start seeing increase in power. So yeah, so we begin to see it in 5 itself. So as you can see, the voltage is varying with the varying irradiance and PV current as well, and so is the power. And at around 11 to 12 you'll probably reach maximum irradiance. So the power falling on the PV panel will be maximum around this period after 12 o'clock. So we would see the same when it comes to the output. So now as you can see, it's stopped at a particular irradiance, because at that irradiance that's the power. So as I showed in the beginning part of this video, wherein we saw that different temperatures have different maximum power points, that's exactly what the MPPT does, right? So it always tries to have the maximum power possible for that particular temperature and that particular irradiance. So it keeps adjusting the maximum power, and it gives you the maximum power output for a given input irradiance and temperature. However, it does not guarantee a regulated voltage. So you'll have to add a DC to DC converter in parallel, or a DC to AC converter as per as your requirements. So now the irradiance is reducing, and so is the power, and the power will eventually become zero when there is zero irradiance. But in this case it won't become zero because of the capacitance effect on the system, and the value of the capacitor has to be adjusted for 24 hours. So you'll have a T, so rate of discharge, so you'll have to arrange that, but it's very close to zero. As you can see, it's e to the power of minus 11, which is very close to zero. So now we'll see the effect of the scope on the scope. As you can see, the green line indicates the power, and the yellow line indicates the irradiance, and the blue line indicates the voltage over 24 hours. So as you can see, the voltage also varies, and so does the power. There's a point around midday where the power is maximum. So the MPPT effectively changes the power for that particular irradiance, and tries to maintain maximum power out, or tries to extract maximum power from the circuit. And so what you would have to do is you will have to connect another DC to DC converter, or a DC to AC converter that regulates this voltage, that regulates the maximum power to a constant voltage. So that's it for this video. Hopefully the effect of the effect of variable irradiance on MPPT is explained, and if you have any queries, do put it in the description box below. Thank you, and kindly do check out our other videos. Like and share and subscribe to our channel.